Just like, is this
Add to
what is this?
live streaming.
Hello, test, test. Hello, hello. All right, everybody. Welcome to the Robotics and Data Summit hosted by Robotics Center of Silicon Valley. I'm your MC for tonight, Ryan. We're going to be getting started with intros shortly, so please take a seat when it's convenient. There will be plenty of time to. There will be plenty of time to chat and do demos later. So, yeah, if everyone can take a seat and we'll get started very shortly. Thank you. All right, everyone, again, we will be getting started shortly. Please take a seat. If you're a Robotics Center station leader, you will have time to resume your conversations later. All right, everybody. Once again, welcome to the Robotics Center Robotics and Data Summit. So the purpose of today's event is to have discussions around robotics and data and physical AI, talk about data, and talk with each other. Check out some of our hardware as well. So we're going to get started shortly, but first I'm actually going to invite our founder and CEO, Jerry, up for a quick keynote speech discussing Robotics Center, what we do, and why we're here today.
All right. All right, so good afternoon, ladies and gentlemen. Welcome to the Robotics Center of Silicon Valley. On behalf of my team, which is all the staff wearing Robotics Center t-shirts, I'd love to welcome you to our new office here in San Francisco, on the nice wash of San Francisco. Thank you, appreciate it. Woo! So today, before I start, if you do robotics, could you please raise your hand so we know our backgrounds here? Robotics people here? Awesome. That's like 1/3 of the room. And who does data, AI software here? Raise your hand. Ooh, that's 1/2 of the room. So for the folks who haven't raised their hand, what do you guys do? What do you guys do?
We just started in robotics and currently are working with SO 101.
Awesome. Congrats to enter the robotics field. So here today, I want to give you guys, we can start with some questions. First of all, you guys might have heard this many times as a robotics founder or engineers, how could we actually reduce the seam to real gap? This problem has been there for the past 10 years. What is changing to make the gap smaller right now? I just want to pose the questions first, and then I'd like to explain how we Robotics Center are making our efforts to help the community to make things better. And the second question is, as you guys might have heard some news 3 days ago, we're going to have more interesting problems with supply chain. So how can we actually accelerate the advent of physical AI with this existing supply chain challenge? How could we motivate and how could we source more things locally and internationally to make better products? And the third question is a combination of both. How can we, at the same time, get more robots being deployed, but how can we inspire more robotics, general intelligence? How can we have a faster loop in between those two worlds, between the software world and the robotics world, so we can achieve this future goal? And our answer in Robotics Center, this is my beautiful colleague Ethan, we call it RL Square. You've been wondering, what is RL Square? Here in this building, we are mission to bring the reinforcement learning and real life together, hand in hand. Because previously, RL is mostly in the virtual environment. It happens in your terminal. It happens in your Isaac Sim, Isaac Gym, etc. But there's not too much feedback from the real life. And there are many reasons behind that. The sensors aren't too hard to get. They are too expensive. And also, to set up a physical station of a robot arm, a cell as we call it, it might take months. And that's why when your RL, your AlphaGo-ish algorithm is competing with each other thousands of times every single millisecond, it only happens 100 times within a year in real life. And here, we have spotted this problem. And that's why, since last year, since we are into YC Summer 2025, we got told by our partner, Jerry, do something people want. We've heard so many people complaining to us, the loop of physical AI into real world is so slow. And that's why here, for us, the name of the summit is Robotics and Data, and it symbolizes basically the marriage between hardware and AI. Actually, somebody will tell you, hey, robots and data in 48 minutes. Why? You place an order to us, but sorry, Friday at 2 p.m. I gotta have my weekend. Next week, they go back to you. They say, oops, sorry, it is out of stock. Somebody bought out the whole stock. I bet some of you guys here have experienced that, not just with robot, but with all the chips. you suddenly realize that even with Jetson or Nano, they're out of stock in Micro Center. We see a huge demand for all those products, for chips, for our storage devices, and for all the robots. And this is a big point because while AI and models ships, in in days, if not minutes, the hardware ships in months. So that's why at Robotics Center, we want to make from 48 days to the slogan you see at the entrance and on the wall. We want to bring them to you as fast as 48 hours because we believe 2 days, we want to have that efficiency to make that available to you and your colleagues right away, to have a faster loop. And as we all know, the faster the loop, the faster you can produce some better algorithm. Obviously with data, compute, but that's a general idea. So here today, I'm very honored to explain what we offer here as a team, something that might get your interest in the near future. First of all, as we said, on the robots, they rely heavily on the hardware. That's why I'll go through all the hardware we have. Just with one single arm, we've got 10 different types. We got the arms, the motors. You see, many of you, have any of people here bought Damia motor, Rock Strike, my actuator before? Can you raise your hand? Did any of you guys buy any of that? Awesome. How long did it take you to get that? A month? What do you get? 4340, 4310? Which model do you get? Awesome. A month. So, for a month, the payroll is high, right? We don't want to waste time in, checking your UPS tracking number all the time. We have them in stock in San Francisco. So we got to the arms, the hands, the humanoids, the quadrupeds, the sensors, tactile sensors, cameras, those multimodal processing units, and then the hands. So we start with the robot hardware, which I'll go through in details, but also our clients come to us. Hey, Jerry, I have to deal with 20 different SDKs, 20 different environments. What can we do? I have to manage this environment, this package version. So here at Robotics Center, we do, our clients always come to us for also support in control. Somebody got X arm from us and Brainco hands from us. How can you control them? So me and our amazing engineers here, we have carried out the Center OS, which will become a hardware agnostic, but essentially we do a lot of internal testing to make sure with the same abstract layer, you can do teleoperation, data collection, retargeting, and make the MCP and CLI available. So you can just next time open your terminal, Claude, and then install Center OS at the scale. And lastly, we know that all the ingredients, as you guys might know, the ecocentric data right now are becoming commodities. You get single-digit number from those data in manufacturers, many residential areas. And we believe the future data relies on diversity and rely on, in many cases, the high quality, which refers to diversity, multimodality, good time sync, etc. So as some of you guys have been to our opening ceremony, we aspire to become the Costco. And it's also because our previous office, which I'm very honored to share with the Humanilla team, who is also here today, we're right next door to Costco Mountain View. And we always, by the way, everything you see here is from Costco. The chairs, the tables, even the speaker, you guys might have seen that on the entrances, to those Costco. We want to become something similar. We want to become your trustworthy, reliable, and next door partner to make your robotics aspirations come to real life. So here today, let me just walk you through the tables, and I'll speak on behalf of my teams here, because we have 30 engineers who have worked for months to carry this show, and not just show, but to carry this demonstration for everybody here. So people always know us by the arms dealer, and they always call this building the arsenal for physical AI war. And we're very proud to work officially with many brands, many of the best brands around the world, including the two beautiful Francas you see at the entrance. And by the way, if you don't know, at the garage area, we got all the demos of all the arms. Slide. We got the Franca arms for you. People always email us, it's the Robotics Center. Can I get a Franca FR3 with a droid setup right away? We tell them, we got you. We have them in stock. We can provide those services to you right now. And then most people, we'll see many beginners, many startup people, many of them start with something that is more hands-on, that is relatively, easy to access. So here, you can already see 4 open arms spreading around the room, made by our amazing engineers and designed by our amazing engineers here. And we are also able to put those wrist cams and hand cams next to it, so you can open box and use them right away. And as you guys might know, there's many other brands, as you heard of, Nero, Yam, Piper, many of the Aloha-ish style arms. We're also available to support you them here with 6-stop and 7-stop bimanual setup. Our team here have also assembled Trojan Stationary AI, and basically we have an operation table easy to use from the start. So we got known more by the arms we sell than the humanoids we sell. But when it comes to humanoids, you'll see the Unitary, Booster, and Noitix one at our background board there as well. And the second thing that we see here is many people, as you know, the quest for egocentric data have been booming for the past few months. But they're not just by cameras. We've seen people just stick their GoPro Hero 9 to their head. How's the quality? What's their FOV? What's their FPS? How do you do time syncing? How can I make sure the hands are in frame all the time? So we see that, as I said earlier, the egocentric data has now become more and more of a commodity, and the world is shifting to multimodality and better, annotated data. So we, the Robotics Center of Silicon Valley, we are proud to work with brands like Wuji to supply the Wuji gloves, Wuji hands, which will be seeing them on the desk. And we're also lucky to host the founder of Wuji last Thursday here at our center, Mr. Rinjo Han. And we're the only place, I believe, to have the Wuji gloves in stock right now for all of the people here today. If you're gonna claim it, you're gonna let us. We have our colleague Ashley and Helen there. You can raise your hands. If you guys need any Wuji support, we are there to help you. And we can also walk you through all the demos. My colleague Alina, could you please raise your hand? And Sarth, all of them have been showing our customers the demos and use cases of how to tally out a Wuji hand. But not just Wuji hand, how to tally out Wuji hand, Brainco, Revo 2 and 3, the LinkerBot, SharkHub, how we're able to control heterogeneous hands with the Wuji gloves that we have here. So we're here to become, and so far, as far as we know, we're the only authorized distributor of Wuji in America. And also, the egocentric data cannot use without vision. So within our stock, you are also available to pick up your RealSense cams, D405, D435, D55, and Z cams and Orbit cams. Some of them are GMSL equipped. We got all the sensors here for you as well. So you don't have to shop everywhere like Costco. You just pick something from this shelf and pick something from the other shelf and get them here to your own cart and just check out. And then, we have so many hardware, but the last thing, I also want to do a big shout out to our team, Ethan Frank, Bryce, Jack Biggins, Jack Shang, and our entire mobile manipulator team. Because we have seen, many customers are moving from lab settings to real life deployment. So maybe our team, raise your hand there, near the M1. Ethan, Jack, Fidel, and Bryce, and Jack Shang, and Barsuk, our amazing engineers with a staff badge. If you have any question when it comes to the mobile manipulator, when it comes to teleoperation, retargeting, our amazing teammates are there to support as well. And after all this hardware, we can go days and days because we are the arsenal for all that. But then I guess many of the people here, you raise your hand as the software people. As the software people, you might feel the world is leaving you behind. Because the development in the Mission Bay, OpenAI, or on the Market Street, they're just so fast. But for everybody here, the real expertise is in those troubleshootings and in bringing the software to make them useful in real life. And for us, many of our clients, we have so many clients asking us, Jerry, I've got an XARM6, I've got a Wuji hand, how can I mount them? How can I control them? How can I do teleoperation? And the same question goes on and on. And that's why here we're able to integrate different SDKs from different hardware together. And trust us, we are one of the capable ones. Because otherwise, our clients will call us at 2 a.m. So here at Robotics Center, we also have, this just went live a few days ago, we have our centeros.roboticscenter.ai, carried out by our amazing software team. Aside from the M1 team, we have Ivy, we have Jack Shang, we have Ripley, etc. We have our whole team here to make sure within one PIP install, you're able to control many things in the library, and you can integrate that as a class skill or other skill to use them right away. So, yeah. And then lastly, before I yap too much, I also want to say a big thank you to everybody who have supported us along the way. So first of all, we really appreciate the support from, as I mentioned, our amazing Manila team, Sandra, Jonathan, and we also appreciate all the guests here who are customers who give your trust to us, and also to so many community events participants. We moved here on the 15th of June, and for the past 5 weeks, we have organized 5 events with over 500 events. We are very lucky to work with DreamFund and Aurora and the Saturday Robotics team workshops, and I believe the next one is tomorrow, but also come to join us, which is going to be a more academic and discussion. And we also hosted the World Cup event 2 weeks ago, even though we feel it's a bummer because Messi lost the game. We didn't feel very happy in the end, me personally. But yeah, we want to become the third space for robotics engineers and founders. We have a big building here, we have 2 floors. We also have some ongoing discussion with people here on the next hackathon. So we also want to have an open invite to all the people here. Feel free to sign up to our email list, which will give you by the end of the event, roboticscenter.ai/list. Feel free to follow our email list. We have a lot of interesting events to bring academic researchers, to bring founders of those amazing companies, and to bring people like you to share your experiences of how to troubleshoot and make your robots work. And here at Robotics Center, we're very honored to become, and as you know, I was joking with my friends, this is also the center of San Francisco, kind of. We're 3 minutes away from the Caltrain station, 1 minute away from the Muni station, and we are in the heart of the South Park and Sonoma area. And we want to make this open, where if you guys want to host our own events, if you want to host our own tea party, if you want to host our own seminars, symposiums, anything that relates to robotics or data, just reach out to our team, contact@roboticscenter.ai, and we want to become your friend, your partner, to bring the so-called abstract robotics term into real life. And we'll support that with space, support that with equipment, and support with our hospitality to welcome more people to know about robot and hopefully to make them a good thing for humanity. So yeah, lastly, these are some of the QR codes, as we mentioned. Feel free to take a scan, and we're gonna also pass this around after the event. And yeah, I just want to say welcome again to the Robotics Center of Silicon Valley, and we cannot wait to build the next generation of robots with everybody here. Thank you for your time for listening. Thank you.
All right, everyone. I'll keep it short so we can get started with the panels. I know that's what a lot of you are excited to hear. So yeah, without further ado, the first panel that we will be presenting is called the Data Wars: Collect, Synthesize, or Scrape. So this is going to focus on kind of a key question that has been going around in physical AI. Where does robotics training data come from? Without fans to the stage and our panelists.
Yes.
Yeah. And also we have some exciting surprise to us people here today, because the interest to come to the event is so much, and the interest to become speakers are also great. So we also very appreciate that DreamFund brings more speakers to us, which are amazing founders in the neighborhood as well. So maybe let's give a round of applause to other speakers, and our marketing team can adjust the slide accordingly. If not, just leave the titles there, and then we can have more people to come to the stage. Yeah.
Who's the tallest?
Thanks very much for the invitation. I feel very honored to serve as a panel moderator today at the Robotics Center, and it's very happy to meet you. And let's start. So in this panel, we are going to talk about the robotics. Currently, we have a fundamental question: what exactly should scale for physical AI to succeed? Is it more demonstrations, more simulation, more embodiments, or better representations, or better role models? So this panel, we're going to explore where robotics training data come from today, where the field is heading, and what will ultimately create the durable advantages in embodied intelligence. So let's start with a brief introduction. So everybody, feel free to introduce yourself, your organization, and the robotics problem you are currently focusing on.
Hello. Hi everyone, my name is James. I'm a general partner at DCBC. We're a early stage venture fund focused on deep tech. So within that, we include robotics companies. My background is originally in physics, and I was in data analytics, so I'm not a practicing roboticist, but I have invested in a number of robotics companies, including one called Lab, which was, I think, one of the first companies to do teleoperation, and we started doing that about years ago. And then more recently, I've invested in some logistics robotics companies, one called Slip Robotics that rapidly loads and unloads trucks, and then a surgical robotics company called Remedy Robotics that's performing fully autonomous endovasculars. ECC has about $5 billion under management, and we write $1 to $5 million checks at seed stage and 5 to 10 at Series A. So if anyone here is raising money in the near future, look us up.
Thank you. My name is Adhay Jain, and I'm the general partner and managing partner for JL Capital. We are focused on very much the energy requirement for the robotics. That's how we come into this space. I have 20 years of entrepreneurship management experience in the past. We worked on a lot of autonomous car and were the early stage of the robotics in the 2000s, when it was kind of a declining, but trying to get some space in there. Right now, we are focusing very much how these robotics data plus the energy equation comes together, because most of the robots are not designed for long-term operations, and they have a lot of challenges when they do some things like 3D operation, going up and down, failures rates, and all that. So we are focusing on how you solve this problem and build that trust with the robots overall. I think the question you're asking in there is what it takes to get a mainstream adoption or enterprise adoption. We think the biggest problem is trust, and that's what we really need to fix.
Thank you. Hi everybody. My name is Evan. I'm the founder and CEO of Chestnut Robotics. Before founding Chestnut Robotics, I was the mechanical engineer at Tesla Optimus, designed the Optimus hand. For that, I was at Apple working on Vision Pro and PD. And my career mostly focused on the hardware and from semiconductor to robotics to consumer electronics. So this is a surprise panel for me this afternoon. Last minute invitation from Jim Fan, and I'm really happy to be here to see a lot of people working on robotics and to see all this hardware going on, data, trying to solve this problem together. So at Chestnut Robotics, we focus on Dexter's robotic hands and data collection on the whole pipeline to supply all this fuel and hardware platform to the big foundation model players and in the future more deployment.
Hello everyone, my name is Chuan Ting. I'm the founder and CEO of Argon Robotics. So I'm also surprised to be here. I just went in and the gentleman called me to be on the panel. So a little bit background about me. Before starting Argon, I was a PhD student at Carnegie Mellon University studying robotics. And before that, I was a mechanical engineering. Right? So at Origami, we build also Texas robotics hand and data packing device. Our goal is to build the best robot hand out there, and also to solve Texas manipulation in the future. Right? Yeah, really excited to be here and discuss about the data packing systems and the robotics.
Hi everyone, my name is Neil Nai. I am the co-founder and CEO of Burn. We are a general purpose robotics company focusing on serving B2B use cases. We build general purpose models all the way from the data capture step, all the way to model training and deployment. We're very excited about the things that we can do, especially around the post-training of these general purpose models to then steer them to serve customer use cases. And we primarily operate in logistics and also light manufacturing. And my background before this was that I was a PhD student at Berkeley. I studied under folks like Professor Fei Li and Jiajun Wu when I was at Stanford. Also had the great pleasure of working with Shuren Song for a number of years. And before that, I worked at Apple for a bit. I worked on funny enough Vision Pro as well, but I was on more of the hand tracking and sensing side. Really excited to be on the panel. Thank you so much, Jerry, for bringing together this group of people and also the amazing attendees, and looking forward to our discussion here.
Wonderful introductions. So first question I'm curious about is, robotics training data is increasingly coming from three major sources: real robot demonstrations or teleoperation, synthetic and generated data, and human egocentric videos. So which one is currently overhyped and which one is underrated? Let's start from Neil.
Okay, so I guess the pressure's on. So I think as all of us begin to recognize, there is a huge data shortage in robotics. Right? Robotics has transitioned from rule-based programs, very much like classical computer vision and NLP, to something that is much more end-to-end. And when we are training these really large end-to-end systems, data, I believe, is one of the most important problems to solve, especially in a scalable way, right? And if you have data that is not scalable or not high quality enough, then perhaps that doesn't necessarily help you get very far. This is very much informed on my past research work, but also my work at Burn. We are big believers in real-world data, right? So we're big believers in scalable methods to collect real-world data that is high quality, right? And so right now, we perhaps are not really betting on synthetic data as much. So, if I were to pick one of these categories to say if it's overhyped, I think some of the more simulation or pure world model work perhaps does not necessarily influence our technical decisions as much at the current moment, right? So instead, we're making big bets on what are good data collection setups that can be minimizing your embodiment gap, but also maximizing your scalability.
So from my perspective, right, I couldn't comment on which one is overrated and which one is underrated, because I think robotics data nowadays is very people doesn't have a consensus, right, on exactly what is the high quality data, right? Because I can give an example for each, right? For simulation, right, you can generate a lot of data in a very short of time, and the best way to leverage compute. However, right, then you will face the shortage of variety, right? You don't have enough objects in the simulation, and also you have to send real gas, because in simulation everything is perfect, the physics is perfect, but in the real world it's much more complex, right? I've been working with amazing simulation company, right? They just do agentic pipeline to convert real world objects into the simulation. Surprisingly, it's much higher quality than we thought. So if that pipeline turns out working, right, then maybe simulation, right, data can be a really good way for the entire field to collect data. But that's still a gap there, right? And for teleoperation, there's a big problem, which is how to scale it up, right? So for people who have teleoperated robots before, right, it's super hard, right? for Creeper it's probably easier, but for Deca scan, without any haptic feedback, right, it's like much harder to like even pick and place right, objects than using Creepers. Yeah? Like didn't even talk about insertion and all in-hand orientation. And the egocentric video data, you can get a large variety of data in a very short period of time, but then there's embodiment gap because human hand essentially looks very different from the robot hand. Yeah, people are working on retargeting method to like integrate or close that contact, visual, and kinematics gap. And there's also hardware ways to solve it, right? So, I mean, the recent taxonomy paper, right, they're kind of using a kinematic matched glove, right, to be able to collect really high quality data. Yeah, that's also something that we've been working on, hopefully, yeah, we'll launch pretty soon.
Yeah. All right. Yeah, talking about data, I think our previous panelists have already covered a lot of the kind of the consensus of the industry. What I'm trying to say here is, I just realized that most of the stuff going on here is about manipulation, right? It's like the part of this robotic challenge. But it seems like everybody is not converged on solving this issue, right? Because everybody already feels like the locomotion have already been solved by simulation. So yeah, that's an interesting observation seen here. So of course, yeah, manipulation data is the biggest challenge right now. But overall, I feel I just want to add on the previous opinions. I feel like all this data will be all valuable in the future. The training will all like fuse all this different data input. It's just maybe different company have different like portions, like weight on different part of the data, how they treat, and also depend on different tasks. There might be certain data can be more valuable than the other. Like even within the manipulation, there are tasks that's very hard to do, and also tasks that's easy to do. Like simple pick and place, you probably can accomplish that with pure synthetic data. But if you're trying to manipulate a tool to find like contact reach manipulation, then you do need a real like zero embodiment gap data. So yeah, and of course, egocentric data can it's the most scalable way, right, to get, and that will form the foundation of all this pre-training model. Yeah, I think.
Oh, sure. I would probably turn people's attention to the ROI of the data. So, how expensive is it to collect each of those modalities, and how much performance improvement do they give you? As an investor, that's what I think about. My companies, they tell me there's a certain amount of money on data collection, and what is that going to give them? So, I will comment on the other thing. Think about if there's some constraint, how much money can you spend? If you can save, but get the same performance, then you can turn that and spend it on something.
So, just to give you a background, for the last 3 years, I have spent a lot of time in Japan, Shenzhen, Hong Kong, Singapore, and of course in Silicon Valley. And I have seen all these experts, all the different ways they are doing the data collection. And when we look at the investment, they are looking at two different problems which could be solved. So one is, everybody talk about data as like, water, everybody, as much as you can drink, this is good for you, kind of situation. But what we look at it is robot is really digesting this data in a correct way, in the right speeds. So hardware and infrastructure problems are still there because we think the RAM and the SSDs, all these like are super fast, super thing. But in this tiny form factors, when we try to do a lot of stuff, things fail much faster. And one of the company we invested in the past, it doesn't work out very well, but what they were doing is they were doing the analytics on the robots, how the hardware perform and which things will fail. Is actually the first thing is the RAM and the disk, because they are utilizing so much data in and out constantly. They're constantly failing. And PFPs are like 1 day, 2 days of the robots if you think about it over the period of time. So what we are looking at is how you reliably create a system which not just work on the computer, but actually work in the robots. How you create a better hardware, better infrastructure, and better ways to deal with the data. Because everybody is looking at a Python library and you throw it in and do a working. We are looking at how the FPGAs can do the data analysis. How we can make the library so small by the time it chips to the any kind of a storage or any type of RAM it goes, it's already filtered out and already decided what action need to be taken. So we literally have to go back, not think in terms of chips, software, hardware, LLMs, and all this library. We have to think about if we cut all these systems and go back to the FPGA level, then how can you do it better? And that's going to be the next evolution. And I'm already seeing this in an international market, and I hope that it will help a lot of robotics company when they're dealing with this lot of data and eventually make the robot reliable with a better infrastructure and hardware.
That's very that's very insightful. So let's move on to the next topic. Do robotics scaling law exist? So large language models demonstrate a powerful scaling behavior. Do you believe robotics will eventually have similar scaling laws? If yes, do you think it will be in number of trajectories, robot hours, embodiment diversity, or interaction diversity, failure examples, or simulation environments? Let's start from James.
I'm not a practicing roboticist, so I would go back to what are we trying to ask when we're talking about scaling laws? We're really trying to project how much investment do I need to make in order to get to the next tier of performance. And for me, that goes to like, what do our customers ultimately need in terms of performance, and where is this kind of most constrained? I've found with a lot of my robotics companies, it's servicing the robot. That is the most expensive thing. Every time you go out and touch a robot, it's deploy to the customer and fix it or swap the component out. That is like the most expensive thing, and it will destroy your margins. And it's a very challenging thing for a business to deal with. And so, what are the most expensive things in terms of performance for our customers? How do we deliver a reliable enough product to our customers that serves their needs, and do so in as much of a margin-preserving way as we can? So those are the questions that I'm asking as an investor.
Regarding physical AI scaling law, I am truly a believer for that. It's going to happen in the next 2-3 years. So as today, I think the whole industry are talking about hundreds of thousand hours of data consists of egocentric, maybe data, teleoperation data combined between 100,000 hours to like 1 million hours. But in the next few years, we're going to push for like 10 million hours to that scale. And I believe this scaling law is going to emerge somewhere in between there. And we're going to see some deployment from happening very soon.
I'm not expert in this part, so I will skip this one, but I would say a different way of thinking about this. Most of the innovation you see in the previous generation of robots, like autonomous car, right? So if you think as a human how we are driving and how the autonomous car drive, they are totally different systems. We are trying to make the human behavior in the robots most of the time, and we are ingesting a lot of data. We did deep maps and hundreds of mapping companies, LiDAR, sensors, and all that thing. And when it comes down to the real driving, it comes out you are actually looking at only 3 sensors most of the time. And when it comes to the critical conditions, then only you look for 5 or 7 or 8 sensors. It's never the case where you are going for more than that. So what's going to happen is we're going to create all these different layers first, and then we will kind of get to the patterns which are going to drive this system in a totally different way. So I'm not sure how it's going to come out, but what we are looking into that is very familiar pattern which we have seen in the drone industry and the autonomous car industry. And a lot of robots, when they are going for a specific use case, they will have the same pattern. That very small number of data or very small specific data pattern, they repeat so much and in specific condition, then the rest of the data, I don't know how it will help them or not help them.
Yeah, I think when we talk about the scaling law of data, we really need to think about like what the use case of this like maybe pre-trained general purpose robot models. Because, for example, for industrial automation, probably you don't need that much of data, right? Like you can like maybe collect 100 very high quality trajectories and can already automate one of the process in a very controlled environment. Right? And I think when people talk about scaling law or this general purpose robot, they're talking more on the application future in home or like very unstructured settings. Right? For that, I also a strong believer. Right? I think robotics we don't see the differences right, between that versus the scaling law of large language models. And there's a recent paper, I think, from MIT Ross-Tendrick group on large behavior model, right? I think like there are two things the like verified right in that paper. One thing is if a robot right given 10,000 hours of training data, if each 10,000 hours is only one task, and then versus like 10,000 hours on like 1,000 tasks, right? People do see, right, given much diverse data, there are positive transfers between different skills. So diversity of data is really important. And also another counterintuitive thing they find, right? One robot model trained on 1,000 skills or 1,000 tasks actually on the single task perform even better than one robot trained on like one task for 10,000 hours. Okay? So that's a little bit different from what humans do because we always talk about this 10,000 hours rule, like for playing piano or like if you get to the 10,000 hours, you'll be an expert. But for robots, seems like it's a little bit different. So diversity is super important when we're scaling up the robot data. And another thing, I talked to Russ and like, what exactly are you, like what's the data format you collect with the 10,000 hours? And mainly he was saying that it was teleoperation data because on the robots, high quality data without embodiment gap right now still is something that helps the model the most. If there's a way to really scale up right, those high quality data, I think will be the future of scaling up for robotics.
I think the panelists have already mentioned a lot of really valuable points. I just want to add a few more. And the first is that I would maybe think about this scaling law question from another perspective, which is the unit economics of being able to achieve the scaling law and what does that actually unlock for us, right? And so if we step back maybe about 20 years and we think about automation in auto plants, right? Automobile manufacturing has been automated for a really long time. But the unit economics of that was horrible, right? You can have a system integrator come in and basically stand up something for you for $500,000, right? And you can amortize the cost over the lifetime of your company with this plant, right? And that made sense for people. So scaling law didn't really matter back then because no generalization was ever needed, right? And I think the vast majority of businesses in the US, right, about 90% or above, and they are going to require a level of generalization, right? All everywhere, right? You have your Roombas everywhere, right? Because that basically just requires no generalization. So I think the very important question that we have to ask is, okay, once we are able to achieve or unlock the scaling law, does that actually provide us with a model such that the marginal cost to automate one more use case is almost zero? That's the power of ChatGPT in some ways, right? And I think all of us recognize that. If you point ChatGPT or Claude at a problem, the marginal cost of that AI model being a domain expert is zero, right? So I think different people have different definitions of that, right? Dente, being one of the pioneers in egocentric pre-training, has suggested that if we can get to 65% performance, right, task success across any task, anywhere, right then you have unlocked basically general purpose intelligence. So I think one way to look at this, scaling law problem is what are we trying to achieve in terms of the unit economics of deploying these robots, right? And I think the second is that when we're looking at the opportunity landscape here, when we talk about scaling law, I think one area that would encourage us to look into more in depth is the supply chain, right? And I think we have aptly pointed out that if we actually do want to scale, do we have enough camera sensors, right? Is Sony able to produce enough camera sensors for the industry in the next 5 years, right? And I think the question is not necessarily a yes. So I think being able to understand the supply chain and especially how we can re-onshore some of this manufacturing is also going to be a critical question that we have to answer for us to even begin to unlock the scaling law here.
Thank you. That's really a lot of hot takes from our panelists. So next, I want to delve a bit deeper into the data problem. So about the successful data and failure data. So most robotics data sets contain successful demonstrations. Should future robotics data sets intentionally collect more failures? And if you have to choose 1,000,000 successful demonstrations and 100K diverse failures, which would create a better robot? It starts from Niels.
So earlier this morning, Professor Sharon Songway, used to work with when I was at Columbia, tweeted that the very simple tweet is that you should not throw away any data, period. So I think in some ways I'm a believer in that. And to be completely transparent, at Verve we still mostly use expert data. We use clean data, right? And I think we're still trying to crack how do we actually leverage failure data in the right way, right? I think a lot of this post-training RL work is very challenging and is still very much in the research phase. But I think my general belief is that we should capture some failure data, and I think that will help bootstrap. Because at the end of the day, as we have more and more robots being deployed, robots will generate more robot data than what we can capture, right? So then learning from that data source is going to end up being very, very important.
So I think I would take the data with the recovery behavior more than the maybe 1,000,000 hours of super clean expert data. For two reasons, right? One reason is if you look at industrial automation, right, you can easily record trajectory or waypoints for the industry robot to point A to point B. Really accurate remarks. 99.9 and 99.9 because there are always going to be errors, right, in your control loop or in your perception. Like we robot learning researchers really generally believe, right, with the machine learning capability we have, we can do more, we can do better than the traditional automation approach, right? So, and to do that, right, you need to be able to experience with a lot of different failure cases actually in your trajectories or in your computation. That's how you're able to constantly improve, right, and boost your success rate. Second point is that if you look at the autonomous driving, who here drive a Tesla? Right? So if you drive a Tesla and if you have a self-driving and you can, probably these days you have like if you break the self-driving and there will be a window and you have to mark, oh, like it's navigation error or it's a critical error. Right? So that is like a method called Dagger, right, which is like a data augmentation that you help Tesla to improve their self-driving. Right? So, and those data are immensely valuable. Right? So if you really want to improve your robot's policies success rate, you're going to have one of those infrastructure in and collect those data to do that.
Yeah, so from my perspective, first of all, I'm not very expert in this. I'm following also this data around like researchers about this area. But just from my opinion, like observing my son, who is like 1.5 years old, like he's doing real world reinforcement learning, right? He's picking up objects here and there, manipulating things. and he's constantly falling, and in order to learn better and better. So my take on this is, first of all, we do need to have a system like at least Neil mentioned and Danfei also mentioned like 65% success rate and above to deploy in the real world, because like you can collect some like intentionally like failed data, but those are never going to be as valuable as real world reinforcement learning. You learn from the real world. So we just need to do whatever possibly best to push the 60% success rate and then deploy the robot and then continue to collect data from the deployment. That's my take on this.
I have a very interesting story about this topic, and one of my friend, he's running this company called InStock, and what they have is a robot which goes on the top and it picks up the bills from the downstairs side and deliver it to the other robots, and they work as a swap. So we were talking together and we said where the things fail, and then he showed me some of the weirdest videos I can ever think of, because these robots goes on the top, and what happened is there is a bin which they were picking up. It was broken, the one of the socket, and somehow every time this bin get anywhere in the system, all the other top bins drop, and they drop with the hook, and the whole robot dropped because of that. Now the question in there was, it always says, oh, the robot dropped from the thing, this is the robot's problem. And the problem was the bin was broken, and every time it sit there, it trips. So the question was, where is the problem? Who should solve this problem? Is it the SOP problem? This is the bin guy's problem? Whose problem is that? And if the robot guy take all the responsibility and say, we're gonna fix all these things, and give us more sensor, we're gonna put more inspection sensor for the bin and all that, that doesn't make any sense. So how you solve this problem, which is a real world problem, and at the end, it comes out, the simple answer was, every time this happen, check all the bins, one time human intervention, and feed it back to the reliability of the overall system, causing many failures, which was not the fault. We think where the problems are, what are the which can cause the problems, and is it the real responsibility of robot to solve? Some are, some are not. And that's something to think about, how we get the exposure of these problems, and most likely the real life testing, understanding those, creating the right process, those things gonna matter a lot more for trust and adoption in this space.
Yeah, this is supposed like a data diversity question. So more diversity, better solutions.
Yeah, and let's talk about the products and tasks. So we talk about a lot of the data, and is there a robotics task category where you believe one data strategy clearly wins? Examples: dexterous manipulation, or humanoid robots, or industrial automation, or household robotics, or mobile manipulation. This is a product question, so let's start from James.
This sounds like a very complicated question. It's like what data would you pair with what tasks in terms of achieving the most performance?
Yes.
Yeah, okay. I do think that with most companies, picking the right problem to work on is paramount. And if you look historically at what companies have made money in robotics, it's largely been AMRs, right? Autonomous mobile robots moving around a warehouse, the Kivas, the Six Rivers, et cetera, of the world. Those have been the ones that have actually achieved good financial outcomes. Now, I do think that is going to change as our ability to deploy robots with novel skills at low marginal cost, right? Like I do think that will unlock other opportunities, but I do think it is important to keep in mind the fundamental economics of the problem that you're working on. And again, historically, that's been warehouse and logistics robots, and then also some medical robots, although there are a bunch of failures there. But at least in that use case, the value of an individual task is extremely high. So the endovascular robot that I invested in, I talked about earlier, called Robotics, you perform an individual procedure that might take an hour, you'll get paid $15,000 for that. Right? There's not, a pick-and-place robot is not making money like that. Right? Even the humanoid robots, we're talking about getting paid like minimum wage or maybe more than that. And so make sure that whatever you guys are working on, like picking a good problem to work on is like order number one. Just like Einstein said, he'd spend 50 minutes thinking about what question to ask. If you're working on the wrong problem, like you're gonna have a bad time if you're trying to start a company.
I will go back to the same autonomous car problem. So when the Uber started, or any of these service companies started, the real problem was we have a car sitting in the home which only use 1 or 2 hours. If we can use this thing 12 hours, 14 hours, 15 hours, and can get somebody paid or pay the economics out of it or some kind of a commerce out of it, that makes sense. That's how with the existing technology of GPS and a mobile app and early stage of this revolution of cloud, everything comes together and become Uber. And that was the whole economics. The same thing we were saying for the autonomous cars, that if the drivers are driving, they're the biggest cost, and then if the autonomous comes, then we're gonna do the same thing what Uber is doing, but without driver, right? So we are still living in that era where we design one system, utilization, define the economics, and every time that fails, then we go back to the state, the start and do this again. So Uber tried to do their own autonomous ride, that doesn't work out. They go back to the expansion of their services into the other spaces. And I think this back and forth gonna happen for next 2-3 years with the robotics, with each product. Because what we're gonna say, it looks like a very good use case for this thing, humanoid can help, and then comes out, maybe not. And it was a very interesting discussion I had in Shenzhen just about 3 weeks ago. There was a group of great robotics companies, 37 of them, and they come together. And I asked the same question: if there is a city where you put all the different type of products, no human and no monitoring, what they will do there? And the question was like, if you are a cooking robot, whom they are cooking for? And if they are cooking for 2 hours a day, is that the best utilization of these cooking robots, right? The same thing happened to all other robots. So if you try to think about this way, if there is an economy which is only for robots to do something without human, that's a different type of thing. Enterprise application, autonomous manufacturing, industrial application, there are a lot of them, and they will have a different use cases. Then you have a with human type of use cases. They will have totally different set of data, different set of problem, different set of errors, and that's going to be totally different. So try to think yourself in this wall, like with human, without human. What you can do, what you cannot do. And the data set and the robotics capability has to cater that side. Because in that side, there's not going to be any human. And in this side, you're always working with a human. So the interaction is different, the sensors are different, which is very different in the other side. So I think that's going to be the very interesting, the future, how we divide this thing. And the general purpose robotics is about this plus this, or they are separate in these areas and even have more branches further down the road.
I apologize, everyone. I actually need to leave at 3 o'clock. But if anyone is raising money, we're working on a startup, feel free to get in touch with DCVC. My email is james@dcvc.com. Feel free to reach out and just reference that you were here and saw me talking on the panel. All right, thanks everybody.
Thanks.
I'm going to be quick as well. So regarding the form factor and where the robot is going to deploy first, I am also a believer of it's either a full humanoid or semi-humanoid, because the reason is not only behind everything built around human ergonomic feeling, it's also about where the data is going to come from. So humans are the biggest source of data generator. So we will continue to distill human behavior and like sensorize human to extract data out of human body and behavior in order to create enable this general purpose robot. That's what I believe. So the hardware and the closer to human environment is going to be the better.
Yeah, so I just double confirm the question because I think that's a really interesting question, and I don't want to miss it. Right? So the question was, is there a clear winner, right, for the specific data type, right, for one specific task, which is like in vectors manipulation, teleoperation, mobile manipulation, right, or locomotion. Right? For me, of course, I will through the vectors manipulation, and I think like there is one clear winner, right, for vectors manipulation, or how we should collect vectors manipulation data. Right? For me, is kind of the block data, right, and I can break it down later. So let's talk about three different ways. So egocentric radio data, let's ignore the simulation first, and then there are block data, and then there are teleoperation data. Right? Or if you're really doing vectors manipulation, you cannot use teleoperation, right? Because you just don't have the haptic feedback, right? You just don't have the ability to control the object in your hand very precisely, right? If you don't have any force information, right? Imagine you teleoperate the robot, use a pen and use it to write a letter or something, right? It's gonna be enormous hard. So teleoperation is out of the way, and then let's talk about egocentric radio data. Right? For egocentric radio data, there are also other problems. Right? There are occlusions. Right? So if you have a camera attached on your head, and then let's say if you're screwing a screw, right? Your thumb probably occlude the screws most of the time, right? And that will greatly affect your model's ability to learn, right, how to like manipulate it, because you don't have the accurate information or state of the object, right? And also, for example, holding this microphone, if my hand, right, is 0.1 millimeter off, right, then my microphone probably will drop. Right? So from pure vision, from egocentric video data, you probably cannot, right, get all the information you need for vectors manipulation. So that's why I believe, right, there should be one way that we can collect force data, which means that if we have a glove, right, it has all the tactile sensors on it, right, and somehow we can also get all the joint information, plus, right, some of the egocentric or camera data. That would be the best way, right, to collect vectors manipulation data, also that gave you force feedback and natural haptic feedback.
I think I will try to be very brief. So if you're trying to do mobile manipulation or humanoids, you might want to do motion capture. And so that's an area that you can also look into. So kinematic retargeting is, can be non-trivial, right? So, but all sorts of data is valuable, and especially if you can find a good use for that data.
I think we are running out of time, even if I prepare some more hot questions. So probably we're gonna leave to the next future session. And thank you. I hope you guys enjoy all the hot takes from this panel. And also one more announcement that the 7A Robotics and World Models Reading Club, we are gonna also host our tomorrow's reading club here at this location. And we are going to talk about the vision, language, kinematics, supervision for perception-based humanoid local manipulation. So tomorrow, 2 p.m., also at this same location. And hope you guys enjoy this session and the hot takes, and a big round of applause to all our panelists today. Woo! Thank you so much.
All right. Thank you guys. Before we have the break, let's do a photo with all the amazing attendees that we have today. So left, would you please move up to the front? We have two shots. One is the more official, and the second one is the selfie, okay? And then let's do it. So, all right.
If you're on the end, if you guys should move.
Yeah. All the staff members, please move, please be in the photo. We're in the photo right now.
You guys move a little bit. Yeah, thank you guys.
Awesome. All right, one more selfie. 3, 2, 1. Awesome. So Brian, yeah.
All right, everyone. Thanks for listening to our first panel. So what the plan is now is we're going to have a 30-minute break, and we're going to get into a second panel focusing on robotics deployment. So during this break, feel free to talk to our team, check out our robotics, chat with each other, grab some food and drink in the corner, or anything like that. And we'll see you guys in around 30 minutes. Thank you.
Good job.
对的，那个 Panel 2要不要加一点那个 How to take panelists？ 这是我的那个一个投资人朋友。
对啊，
可以。
可以啊，可以。感谢你啊，谢谢你帮我打动朋友。下次可以一起合办，这样
可以。
这次也算办合办，不是我们中文的合作。
可以，对。哎，我觉得刚才听有 How take 有录像吗？
全程，全程，我把那个关一下。
可以。
here at Scale AI, where I led strategic product management across computer vision and also Gen AI. I invested in Dyna Robotics, it's a pretty well-respected dexterous manipulation startup in the Bay Area. And just to answer the question directly, right, like our general thesis when we invested in Dyna was really about performance as the product, right? So in a lab demo setting, you basically get the one perfect clip of a job being done, but actually once deployed, the customer is actually holding you accountable for performance SLAs. So ranging from quality of the task completed to the throughput, right, the number of jobs completed in a period of time, and also trade it off against cost of what it actually takes to for a customer to actually replace a human with the robot to do the job. So I would say like even at deployment, it is a process, right? So from pilot ultimately to what could be like a long-term production contract. I would say the ultimate sign of getting true product market fit, kind of following the enterprise AI deployment side, right, is basically how do you go from that pilot to scalable production phase. So that's the true test of demo to production.
Hi, I'm Django, and I'm the founding VP of Exodus Capital. We're an early VC firm that invests in pre-seed to Series A startups. So if you believe that your startup will be the next Anduril or SpaceX is in 10 years, talk to me. Dyna Robotics was a great investment, so congratulations on that. I'm quite jealous of you getting that allocation. I was reading, I think his name was Jason Moss, DeepMind papers before, and then wanted to get into that, but ultimately did not. So the threshold that we look at is not even between like demo and deployment. That comes, that's like way before what we consider investable. I know this is not answering the question, but I think this is what's more relevant to people here. It's that once you have a prototype that is deployed in a production environment and you take the learnings, like all the failure modes, that's when the real value is accrued. And so when we look at the robotics stack, we look at, like the hardware and then the software foundation models and then deployment. And so to answer the implicit question of where the value is, it's where deployment is had. And where all the data gets compounded for you to actually have a robot in the field that can do the task at 100% reliability, which in the United States now, it's not there yet. And I would say we're a few years out before we can see ubiquitous, reliable robots out in the field. So yeah, I would say like as an entire space, it's we haven't even broken through there yet.
I have a follow-up question about that. When you said like the United States is a few years, I guess like early in terms of deploying in the field, like do you think there's any other country that's ready for field deployment, or like why do you think specifically deployment in the field versus, because a lot of people say like deployment in the field is ready, but deployment at home or like other like consumer settings is not. So curious to hear your thoughts on that.
Oh yeah, I mean, deployment in industrial settings or like farms in the Apex context is comes before the consumer setting, like way before.
Right.
Yeah. So I mean, like, yeah, you could have like a 1X Neo or whatever in the home in the next like year. But
This year, for sure.
yeah, but it's like, well, you tell me, right? It's largely going to be a statue that you could tell it's not going to be autonomously like chopping your fruit and like putting your baby in bed.
It'll surprise you.
Alright, surprise me.
So to the production question, I can read into that a few different ways. By the way, Terrence, Bay Area Robotics. There's simply success rate. So like as you break down tasks, what is the actual success rate on the line? That can be sort of a moving target because you can break any job into any different number of sub tasks, right? And so it's about finding that balance between what the robot's able to do and what its actual ROI, right? And then moving that over time. Evals are obviously a huge part of that. How evals are being worked back into the model and actually successfully integrated is another really important metric that I'd say I hear a lot from startups as being something they're highly focused on, just making sure they're actually kind of hill climbing, they're actually sort of moving forward, right? And then the production can also mean production of the final robot. Like, is this designed in a way that's actually ready to scale? Have you built on? Is that better? Okay. Have you built on systems that in supply chains that actually are ready to meet ultimate demand, right? I know when we're talking about onesie twosies and pilots, it doesn't seem relevant, but it's absolutely relevant as this whole ecosystem gets off the ground and starts moving aggressively forward. So these are all things that I'm thinking about, not just because I'm talking with startups, but I'm talking to component manufacturers, I'm talking with governmental organizations, I'm talking with multinationals that are looking holistically at this ecosystem and asking questions about that just doesn't work, but if we actually go to market with this, if we go to like actually move, can these supply chains actually support us and move with us?
Yeah, when you talk about evals, could you elaborate on that? I think it's super interesting because I think the market doesn't really have a benchmark on any of the metrics, whether it's like data eval, like what makes a good model versus like other not so good models, or are you talking about like production eval? Like, yeah, I'm super curious to hear more thoughts on that.
I mean, yeah, this is probably like a sum it all on its own, right? What I'm thinking about is as a robot learns a task, are those learnings actually properly integrated into the model through new iterations, through additional iterations, or are you sort of to use the analogy, sort of is it like the dog chasing its own tail? You're actually not. You're sort of moving through different model versions, but you're actually not moving forward.
Yeah, that makes sense. I guess move on to the next question. So when we talk about success rate, like, do you think 99% success rate is good, or do we must have 100% or close to 100% success rate? And do you think that's like a benchmark for defining whether the deployment is ready or not? We can start that here as well.
Yeah, I feel pretty opinionated on this. It absolutely is about grinding the nines. So for actual production use cases, right? Just imagine, well, first of all, like the way to think about success rate is actually to flip the equation around in terms of error rate, right? So 95% success is actually 5% error rate. 99% is actually 1% error rate. And to actually go from 5 to 1% is tremendously difficult. So first, it's a very tough problem. That said, like the customer is really not going to care, right? Of whether, well, they will care that your robot fails, and that's one way for them to churn, right? But fundamentally, they're really focused on jobs to be done, a certain quality and throughput to ensure that the job is done in an efficient and effective manner, right? And then for them to actually pay money for this, like it really does have to be in a case where you ground down the edge cases and gotten to a level of performance that they are truly willing to pay for it, right? And I'll just give you an example, maybe a consumer example, right? Like, let's say like the job is for the robot to clean your room, and then there's like lots of various objects, maybe like a cup of water or glass somewhere, and like if failure is like the robot dropping the glass and breaking the glass on the floor, like that's not going to lead you to have a happy customer, right? So absolutely, it's about grinding the nines, and like what we found is those that can effectively handle all the edge cases and actually do this in a live deployment setting are the ones that are going to have like a compounding advantage because they have that closed data feedback loop to then feedback into the model training processes to basically have that data flywheel compound over time.
You took the words right out of my mouth. I think we think in a very similar way. And I, just to reiterate what you said, but like framed in a different way, it would be like, in In the factory setting, the stakes are much lower. And so, if you're working with a customer that requires 95% success rate, and maybe you're doing a pilot, and it's strategic for them, their tolerance is much higher. But in the home setting where, it's like, we're saying that the home setting is the gold standard for robotic safety, where going from 5% failure rate to less than 1% failure rate, the scaling curve goes exponential. But that's how high of a standard you have to have in that setting, because again, for example, in like a higher stakes example, if you have like your robot trying to like cook for you, so it's like chopping something, and in like 1% of the cases it throws the knife at you, is that acceptable? Probably not. But in the factory setting, right, it fails and like it flails or something, and then like it hits the wall or something, damages the robot, that might be okay. No humans are hurt. But in the home environment, you have like babies involved. You have like, you need like robotic insurance for your home robots in case any of that happens. So
I actually think in the home setting, like it's more acceptable, like failure rate is more acceptable than the industry setting. Mostly because like on an industry production line, like if you fail on one task, then the whole production line gets impacted. And you would have to have the human in the loop fixing the whole, like manually fix the whole production line. And that would not only disturb the whole robotics, obviously like workflow, but also increase more human in the loop hurdles. So yeah, I actually think success rate matters way more in the industry setting than the home setting.
I think it depends. Well, for starters, I've never heard of robot home insurance, so that might be a future business idea for someone out here.
it's coming.
I'm sure it is. So I'm going to say it depends. I think what is the error rate, right? How often is the error rate? If you let's just use the example of the figure robot sorting packages. If it does a package every 2 seconds, and the error rate is 1%. I love that framing, right? That's a human coming over and fixing something every 2 minutes. It's not very useful. You just put a human on the line, right? So this is the problem with comparing side-by-side tasks, and this whole like moving from the digital to the physical realm is like it's so hard to actually get common comparisons and metrics. And every single task that a human does is broken down into subtasks, like I was talking about, and they're all somewhat unique. Even two humans will approach the same task differently, right? So it gets very hard to actually tease out error rate and how it actually affects bottom line ROI, which kind of goes back to this whole deployment. The challenge of getting these robots is deployment and being able to meaningfully reflect quickly, at least, where the pilot performance is and what makes sense from an economic standpoint. The businesses that are going to really see long-term value in this are going to make this sort of a jump of faith that this is the future, and they're going to invest long-term and not just do like a 3-month pilot and try and compare the numbers. Because it's never going to be how these models, how these robots are able to actually provide value.
Cool. Yeah, since we're talking about pilots and deployment, I want to jump on to the next question. What do you guys think is something that only shows up during deployment, maybe like 1 to 3 weeks into the deployment, but not during a pilot? Based on you guys are all like either invested in robotics or operated robotics companies, so based on your personal experiences.
I can just start off real quick.
Sure. Yeah.
There's a sort of consumables aspect to this, which is kind of fascinating, right? Whether you're selling wearable gloves like the back, or it's a robot using its hands, you'll find that the fingers break, the gloves, the fingers of the gloves break, actual fingers of robots break. There's a failure rate that is somewhat unexplored because we're using, we're fundamentally reinventing the use around these technologies, right? Actuators have been around for a long time, but the way we're using them, the way we're miniaturizing them is very, very novel, very new. And what I'm hearing is sometimes the failure rates are much higher than anyone expects. And so whether it's like a fundamental design approach or whether it's just working out the kinks, will be interesting to see. But I mean, sometimes like you don't ever think of like a finger as being a consumable that you got to replace every few weeks as a human, obviously. but that's the case with robots. And so it's just a really interesting kind of weird rethink. Yeah, I'll leave it at that.
It really depends on the application. I'm thinking of ag tech specifically, and there could be a specific design that you made for, like, I don't know, like 10-inch crop rows or something, and then you go to a farm and it's got like 20-inch crop rows. What are you gonna do? And they have to like build a completely different prototype in order to satisfy the different environments, like these non-standard crop rows. So it's just a lot harder to account for these things as a robotic business without the economies of scale to manufacture your machines.
Yeah, I would say in general, like a lab setting is basically the perfect environment, right? And then, so you can think of like before you ship the robot as, hey, here's the planned approach. And then once you deploy, that's when you get punched in the face. So I'll give you a very specific example. We were diligencing Dyna, right? So I went to the office, saw their robots folding napkins, and then I actually went on site to the customer that they deployed at. And the environment, like there are so many different factors that happen in real life. So one example is where it's deployed, the lighting could be different. There could be environmental vibrations that could really impact how the robot operates, right? So like categorically, the performance that you get in a lab setting is going to degrade in a real life setting, right? And drawing from the ag example, right? Like once you have a farm robot deployed, then you have to deal with sunlight, dirt, all these exogenous factors that you just can't like model inside a lab, right? So there's definitely like a real impact, and it's really once you get into the real world setting that you basically learn through iteration and find out after the fact.
Move on to the next question. I think so when we talk about intelligence, we talk about obviously like the data flywheel, about improving the model, about like all the long tail stuff. So what do you guys think, or I guess like to what extent does intelligence stop being important and does the problem move to somewhere else?
Go for it.
Yeah, I mean, I think where the models are right now, you can get a lot of lift across the whole model training cycle, right? So from pre-training, post-training, there's lots of like new approaches here to just improve generalization, like single brain, multiple embodiments, right? So that's like one area of intelligence at the pre-training, post-training. I think there's still a long way to go. And then of course, there's like the whole mid-training, post-training eval cycle, right? And so you can think of that phase of the intelligence stack, so to speak, is really like the last mile of grinding the nines, figure out all the out of distribution edge cases to get to that performant level. So I think like where we are today, right, there's like lots of opportunity across the entire training loop. But ultimately, right, like I think when we talk about the robotics data engine, right, like you basically need that end-to-end flywheel, right, culminating in the real-world deployment that then you can get the true in-environment evals that then feeds back into your model training cycle, right? So I think, well, I guess like to answer your question of when intelligence will end is when I guess we get to more of like the incremental gains in the model training that we're quite frankly pretty far away from, but I think will happen over the next few years.
I would zoom out a little bit and implement a sci-fi metaphor, which is the one from the Matrix, where remember like you could download a floppy disk or whatever, and you just download a bunch of skills within a couple of seconds. I would imagine something like that would be possible for robots as well. I'm not like super bullish about any individual foundation model company or world model for that matter, and more so that there would very likely be a future where there's like an app store of different skills that different people submit it to, and then, you know, you, like robotic companies or and customers purchase, like gated APIs or something. Yeah, there would be like an app store of behaviors and skills for very niche things. The foundation model company can't do it all. They're not going to be able to, like solve 100% reliability for, I don't know, chopping fruit, and at the same time be the experts in like various polymers for like 3D printing something, and like be really good at like underwater welding. So there's going to be very niche cases where individual startups are going to do these things really, really well, submitted to probably an app store, and then that becomes, you know, potentially like an orchestration layer for different robot fleets for different form factors. You know, I think that is very possible in the next like 10 to 20 years as robots become more ubiquitously deployed across the world. Yeah, so it would be like a major thing.
I was going to jump in this question because call me sort of an AI optimist, but I sort of see intelligence as solving all problems. And you can imagine, you know, in the not so distant future, robotics that are being the Costco of robots, and robots just like walking in on their own and recognizing they've got a broken finger or whatever. Like urgent care for robots, you know what I mean? At a certain point, like these intelligent systems will start to forecast their own maintenance, understand their own needs, be able to predict their skills that they have, that they need, that they don't have. So I think the world's gonna get really, really weird in the next few years. Whether that's a few years out, whether that's 10 or 20, is sort of the big question, right? Horizons or everything. But I think that's definitely the direction we're moving in. So I'd say with strong affirmation, intelligence solves everything.
Yeah, totally. Actually, in terms of failure, that brings me to my next question, because I want to zoom in a little bit and talk about specifically the data layer in terms of the whole intelligence suite. When we have deployments in the real world, obviously we'll have much more diverse data from like real customers, but at the same time, it's also like much more customer specific and with like much specific like environments, scenarios, etc., and less about like, you know, the diverse failure paths that we can capture, because obviously like we're not collecting data in a deliberate setting anymore. So do you guys think having more data in the real world is actually a good thing or a bad thing in terms of deployment?
I'd jump in and say not all data is created equal. There's a sort of mad rush right now to just create data for models and for training. And the problem is a lot of it's garbage. And if you model fake behaviors in the real world and you train on that, it doesn't necessarily relate to real behaviors. And so it's not just more good data is definitely better, but bad data is bad, right? And, you know, I've got a 5-year-old, and if I teach her the wrong way to do something, it takes a lot more work to unlearn that skill, that habit. And I think that parallels pretty well to world models and to what we're seeing for actual vision models and others, right? So I think it's really, really tricky. It's we don't really know like what is going to be the ideal data sets, whether it's pure egocentric or whether it's a combination of sensors and egocentric data. So I mean, this is sort of, I think, the most exciting, most interesting part of the field right now, because like, we're really on the bleeding edge and no one really knows what's going to work. And you got hundreds, maybe thousands of teams trying different things. So the question is like, what is good data look like, and how wide is that aperture?
Yeah, I mean, I would say like generally all data is useful data in some way, shape, or form, even like the failure data, right? I think like similarly to how software and agentic workflows have evolved today, I think robotics will likely follow a similar pattern where as you collect more data in the real world, it's actually going to lead to, well, one, more evolution into the workflows. So workflows aren't going to be static, right? Once you master a given task, then there's going to be more tasks that will be assigned. So like longer term, it will actually lead to more like more use cases and more data that will be needed. Longer horizon, more complex, right? Similar to like kind of like how I think agentic is evolving, right? To more long horizon tasks across multiple different environments, right? I think that will, that's my assumption at least, how like robotics will evolve. And anecdotally, like from a customer's perspective, their workflows are never going to stay static. It's evolving over time, and so I can generally assume that like as robots get into the real world, it's actually going to lead to more useful data due to a combination of like more tasks, more work to be done, assuming the robot is successful.
Cool. I know we're at time, but one last concluding question. If a founder came to one of you guys with a perfectly working demo and say, like, what do I need to do to make it work in deployment? Like, what's one thing you tell them?
I would say be prepared to do the heavy lifting by deploying the robot. I mean, at the end of the day, like the first thing about deployment is probably just to be on site, be very high touch, white glove, contributor or really driver of customer adoption, because only then will you kind of like learn the muscle and like ability to basically bring what is like a completely new product into a production style of deployment, right? It's very similar to the software side where, you know, today there's like the whole forward deploy motion, right? But what does that actually mean? So I would say it's next level more difficult for robotics because it's in the physical world. You can't actually do it behind a screen or a Zoom call, right? So, but yeah, I think the pattern still holds because at the end of the day, if the goal is to get to 99.999 whatever, right, like level of quality, it is going to require a fair amount of heavy lifting once you deploy.
Yeah, I would say that the hard truth is that as an investor, even in the pre-seed stages, if I know you have a prototype that hasn't yet been deployed in the real world yet, it's largely not investable. And so it would be, you know, prudent on you to either have an unfair advantage in the sector that you're competing in, or select highly strategic investors who could get you into the world of deployment so that you could get past that hurdle. Yeah, like one example would be like, let's say you're building something to do with space. It's very difficult to get the inroads to even send a payload to test how it would operate while in space. So if you don't have any inroads there and you just like have simulation environment, you like want to play a robot in that kind of environment and make a whole bunch of assumptions without knowing how the materials would erode or something while up in vacuum, it's largely useless. So, yeah.
I would tell them it's always dangerous to build a product and then go try and find what it solves. I think there was hope that the humanoid would be different because humans are everywhere and the world, we built the world around our own form. But what I'm seeing again and again is the robotics companies that are really successful have kind of like a SaaS company, really deeply understand the problem, understand the problem frankly better than maybe even that customer does, and then they build a solution tailored to that problem. And I think robotics is going to be the same for a long time. And so it's not that you can't be successful just building a cool robot first and then shopping around trying to find the solution, what it solves, but it's much riskier or difficult way to go about it. I think it's kind of mimicking what the other side.
Awesome. Thanks, everyone. Let's give a round of applause.
All right. Thank you to everyone for coming to the Robotics and Data Summit hosted by Robotics Center of Silicon Valley. So with the time that we have remaining, feel free to walk around, chat, check out the robots, and do all that. Thank you, everyone. And if you have any feedback for our event, there's going to be an anonymous feedback form here, so feel free.
Thank you guys for coming.
Great collaboration.
They'll get drive and everything. You guys can post specifically.
Yeah, I guess there's quite some context. If we have a transcript of the first, so
We can get it. 'Cause Jerry was, I guess, like live streaming or like recording or something like that. So I'm assuming we'll have some sort of transcript.
Okay, yeah, that's good for LinkedIn because I think
Make a LinkedIn post about it.
because I'm online, so I have to pick which question is the control the time. So some hot takes maybe I was not really pay attention to, but I think
So you guys are helping.
Yeah, of course. I'm glad to see us face happen.
Yeah, you guys will be back tomorrow too.
Exactly. At first I heard that there is because 3 panelists and one is 22. And I was assuming maybe
I think that was good. Yeah. I think that was good. Made it feel more lively.
Yeah.